Hello, hi. And it's a wonderful day out here because I got a nice idea. I've gotten several more nice ideas. Hardcore chemical engineering. It's like having, hardcore, what? Sexual intercourse. All right, doing these three experiments. So you work away and, things could get good in your direction. You could get jobs. You could get published. I've been waiting forever. But this was a brainwave because the chair of the department, whose course I had all sort of sat through when I was working as a research associate in the Department of Chemical Engineering at the University of Toronto. Since then, he switched to environmental waste management, etc. All right, environmental engineering. But he was teaching combinatorial mathematics. So, as he said, it's a Freudian slip. I thought I could, because this was from Professor Clark from UC Berkeley, who's also incidentally the editor of Biotechnology Bioengineering, Doug Clark, and this is from Inferno. So Doug Clark had years ago, it all clicked in me all of a sudden. Combinatorial mathematics, how to work this out, etc. All these, you know, click. But there you go, eureka moment. Archimedes and everything. So all of a sudden, uh, he had said that he does combinatorial mathematics, combining enzyme kinetics and microbial kinetics, bacterial kinetics. So I thought I would do this. All right. So I had to go through combinatorial mathematics. The notes I had, my then supervisor, Bradley Sewell, who's turned a little strange, Dr. Jekyll and Mr. Hyde kind of a scenario here. And, Voldemort at times has helped himself to the notes. Yeah, from the lab that I was in. He could, but that's not right, though. I mean, the principle, it's not right. He was paying me, so he could do it. But then, the principle of the whole thing. So he has my notes. So I don't know what Professor Furnout said in the class. All right, he taught integration and combinatorial mathematics and, Freudian slip and everything. I'm hoping this Freudian slip is going to be, somehow God saw to it that I remember Professor Furnout earnestly teaching away mathematics to us. And that's going to get me there at heaven's door, into heaven, getting published and paid with, with whatever reasonable sum. I've helped the department dispose of hazardous waste with my own equations and things, and then everything. But then they checked it out. All my equations, enzymatic catalysis. So they checked it out with actually doing small reactions, and so both ways, give and take. So so I looked up the internet, and I'll give you the reference. Discrete and combinatorial mathematics, discrete and combinatorial mathematics. So this it's a PDF file. So the author, I have to go back when I'm actually writing it out, but it's going to take me a while. So this here, who is it by? Ralph P. Grimaldi. Ralph P. Grimaldi. And I chose the first one that is there, polynomial ring polynomial ring combinatorial design. All right, so there's an addition there. F of x, you express it as a polynomial with coefficients, g of x as a polynomial with coefficients, and then there's just a neat pattern, and that's the answer. So I'm going to do an experiment now. Collect experimental data and then express these as a polynomial. And then, the addition is right there. So the coefficients play a huge role. All right, but multiplication, another time. I'm supposed to turn this in by 9:30, and I have to make dinner. I'm heavily deprived on sleep. Yesterday, my son came with his girlfriend, and I cooked for 2 days. Mexican pie and burfis and save and Mexican veggie taco. The works. I have a taco folder, and it all comes out nice and folded, and then Kannada thing, kai saswen, and coconut mustard rice with mustard bhaji, raita, and the works. So I'm saving this. Nicholas Menton, you should see. UFT has has a memorial for The lady is Menton, I think. Or either she Michaelis. Michaelis would be, she was the researcher. Michaelis. So because I'm Sita Raman Civil always. So I have to do 2 substrate concentrations and microbial fermentation. There's an exponential growth for bacteria, and the community bacteria dies. So you reach half-life very pretty soon. I hope, because I'm just doing the experiment for maybe 15 minutes, and so by 16 minutes. All right, 4 minutes, every 4 minutes data points. And so I'm going to do 2 concentrations, and I'm going to try butter. So there's this wonderful product, bread dipper. You try bread with this bread dipper, and it has wonderful things in it. So it has balsamic vinegar, which makes it a little tangy, sour, tangy. And so butter, I thought, could do the same thing. So you could add bacteria and make it, ferment the butter, and reduce the fat. So lipase. So I got these 2 enzymes, two extra enzymes here yesterday, and lipase in one. How much do I have? Lipase, I have 50 milligrams in this one. And in this one, I have how much lipase? How much lipase? Lipase. Oh, I don't even have lipase here. Invertase. This has invertase. Oh, there's triacylglycerol lipase. And how much do I have? Oh, this is an awful tiny amount. 30. Oh, farther away, 31.25 milligrams. 31.25 milligrams. This is. So smaller amount, so less of enzymes. So 1 substrate concentration, but I have to take the same amount of enzyme, won't I? So we will just do the digestive enzymes less later. All right, another time when I have other experiments to do. So I've melted some butter, and then these are probiotics. Actually I've had a cesarean section, but then the dictates of sisterhood. So I keep that probiotics and just flash them around, but just in case things get out of control. So probiotic. No, I'm kidding. I hope that things never happen to anybody of this, this sort of thing. But in the washroom, sometimes it gets out of control. I'm honest, all right? So 5 types of bacteria. So I'll just do this one. 15 billion CFU. What's CFU? Cells for every unit. Cells for you. 15 billion may be a little much. So it's not. This is 10 billion. Jameson, 10 billion. Maybe I do 10 billion. But these are. This is. There are a number of bacteria. Multi-strain probiotic or probiotics. I'll do Jameson. This and this together. Can Pro for another time. Can Pro say so I have melted butter, and butter is melted. So I'm going to add I'm going to add 1 tablespoon, 4 points only. 1 tablespoon. We'll see how many 2 tablespoonfuls on the second one, or 1.5. 1.5 on the second one. 1.5. 1.5. Only 3 points. Oh, this is disappointing. But that can be, just 1 and 1.5. So 1 tablespoon of melted butter. And where is my notes? So 3 points only. So this is going to go fast. 5 minutes. Every 5 minutes I'm collecting points. Pen. Give me to So by Gayatri B. Sitaram, my name, 1, 1, 2. So we do 0, 1 tablespoon, 1.5 tablespoon, and density for one. That should be on the internet, right? Melted butter density. So 5, 15, and 20. So totally I have 4 points. 0 times 0. T equals 0. So this is 1.5 tablespoonfuls. So density. All right. Or should I take the math? It's too late to take the math now. So I'm starting the experiment. All right. This. So 50 milligrams of enzyme. 50 milligrams of lipase is in this. And probiotic 10 billion cells. Bacteria. All right. So ours, actually, bacteria, live for a long time. But we hope that they're going to croak soon here, because so I'm waiting. All right. So stir. Seal. I have to break the seal. It's a new box. Okay. So, new box. Getting got flustered here. It matters a lot, right? Getting the experiment right. 2. So enzyme is the same. Substrate has changed. That's also enzyme is the same. And the probiotic. 1, 1, 1, 1, 1, and 1. Okay. Stir. Reaction's going to start. So this is 15 minutes. So this is again iodine stir. 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 Okay. Same amount of enzymes, same amount of bacteria, different substrate concentrations. So I am working away. You can see me stirring. Working away. Keep an eye on the watch. Maybe get the watch closer. Get the watch closer. Timer. Closer. Square that, is lucky because Bradley Sewell didn't have his Dr. Jekyll and Mr. Hyde personality. So swear, we just do these two. Stir. Oh, Ticking. So we have enzyme kinetics. You'd have to do the slope, and here, product. I would have to see the product. There's a curve in Livensfield, so I would have to see the cells, the product of the cells, and cells half-life. I hope we reach the half-life soon. Taste assay has said, but maybe the last one. I'll see the taste assay. Oh, it's not good. Come. So this is an Niagen, as I've shared with you, the micropipette assay. So you get an accurate estimate. Otherwise, normally you take out some, and then for small quantities, micropipette assay is really good. So industry, university industry. Okay, so this is all right. This is a little less than. This is 2.5 mil. So 2.5 mil. So I can zero this. So 1 tablespoon is 5 mil. 5 mil. 50% have taken 2.5 mil. The weight is about 25 by 6, 25 by 6, 2.5 mil, 25 by 6 grams. And I'll check this as I leave this here. This. So this is 2.5 again. 2.5. This is 15 now. So this is 2.5. This is 25 by 3. 25 by 3. Oh. Okay. So taste assay in the end. I'm going to try each. A scale of 1 to 5, which is the sourest. Butter has no, has a rich taste. So sour, and obviously lipase is reacting, and it's reducing the fat content. So it's a low fat. So the bread dipper is olive oil. Olive oil, extra virgin olive oil. And some good things. You should take a guess. You should buy your own bread dipper and take a guess. Two 2.5 mil. This is 25 by 5, I think. 25 by 5. 25 by 5. 2.5 mil. And 2.5 mil. Yeah. This became 5 mil. This became 7.5 mil. 7.5 mil. 25 by 3. 7.5 mil. 25 by 3. Oh, not 7.5. 2.5 plus 1.2, 3.75. 3.75. Last point. Last point. Last point. Could I assume, like, sudden death, the bacteria died, but the calculations should point to it. So I'm going to. So I would be guessing it from the bacterial curve in Levenspiel, octave Levenspiel. So I wonder why mesenchyms and civil don't have anything on microbial fermentation. I suggested to Professor Phillips that she, to professors, or Professor Mims included, one of the authors, and civil, that Professor Jane Phillips should write a chapter on zeolites. She did a thorough job in her course, Industrial Catalysis, gave us the right notes and exams and everything. So we used, I used zeolites as a support for enzyme immobilization in both my MNG and MSc thesis research. I think I can possibly use this because, for cooking, because there's bad, So I'm going to assume that bacteria, follows the curve pattern in the book, and then see at what level it would, at what time it would reach, half time, half life, half time. Freudian slip. Half time, half life. Today is probably NBA. Yesterday was the rest day. One more minute, 1 minute to go. Timer goes off, and I take the measurement. The milk solids have are more in one, less and lesser in two, and 0 in 3. So slide base is doing something. So is the bacteria. Take this out with a tissue, don't you think? Yeah, that's why I said be putting it in the drain. Transferring the goes off. This would be an incredible amount of work. Measuring an analytical balance, and it would take a whole day. So it was a trick taught to me by a friendly source that you should take, because I was measuring, and so this is it's taken out all milk solids. It's become okay. This it's 2.5 mil. 2.5 mil. Oh, it's actually it's 5 mil. It's 5 mil. 5 mil. Five by 4, 5 mil. 25 by 4, 5. Into 4.5. Okay. This is also 5 mil. 5 mil. $25 by 4, 5 mil, 25 by 4, 5 mil, 25 by 4. So these are my values. I'm signing out now. If you have time to do valid summer work, work, right? But then, you could get ahead. But then your professor is going to say, you listen to me, and then you get ahead. What I teach you is what you should know. So go out, enjoy a movie, or I just check out my results. Enjoy a movie, or watch TV, or sit in front of the computer. All right. Signing out, Gayatri Sitaram. Thank you.